So thank you, everyone. My name is Amin. I'm here to present Avicenna here. It's been almost 13, 14 years that we started the company. And since 13 years ago, we've been involved in different research projects. And I'd be more than happy to walk you through some of the features of our platform. So let me share my screen here and then start this presentation. So we're sharing the screen here. There you go. Okay, great. Can you just confirm if you can see my screen?
Yep.
Great. Okay, thank you. So what is Avicenna? Let's just start with that part. So we offer a participant-centric research platform that covers, end-to-end process of the research. We automate the entire research process in general, and we help researchers to automate the data collection part and analyze the data and communicate with participants when needed. So here's an overview of the platform. I want to very quickly introduce the platform and go through, a high-level feature sets that we offer here. And then after that, I'm going to focus on the data collection part from the participant's perspective, the data journey through the pipeline, as well as some of the features that we offer to help you with the compliance monitoring of the data on the researcher side. So let's just start with a quick overview of the platform. Here is, as you can see, um, the platform has two sides. On the right side, in this picture, we have the researcher dashboard, which researchers can implement, sign up as a researcher, implement their protocol, create a new project, and then, adjust all the details of their project and all the bits and pieces. For example, what kind of data I want to collect from my participants, how exactly I want to collect this data, how exactly I want to communicate with my participants, and like interventions or reminders and notifications and all these details. And when people, researchers implement the project and they deploy, and we save everything on our databases. And on the other side, when we deploy these research projects, these protocols, participants can use one of our participant applications, which in this case, we offer Android, iOS, and web-based applications for the enrollment, to enroll in researchers' projects. So the way that we actually collect the data is very brief overview of that part. When we collect the data, we encrypt everything on the smartphone side, and we wait for the secure data collection, network, and then we send everything to our databases, and the server sends an acknowledgement, message to the participant applications. So the participant app removes the local instance from the phone, and then on the other side, researchers would have access to all the data that's collected. So this makes it very easy for both sides. One, because one reason is that on the researcher side, the only thing that you need to work with is the researcher dashboard, which we gather data from different sources, and we put everything in a tabulated, fashion, and present everything and visualize everything on your dashboard. You don't need to work with different platforms. And similarly, on the participant side, they only need to install one application in most cases, if technology was that is possible technically, and that's the only thing they need to do, and which increases the compliance rate on their side as well. And the entire process is compliant with FDA CFR Part 11, HIPAA, PIPEDA, GDPR, and ISO 27001, which allows us to work with like academic research. We can work with any research supposed to run on clinical settings and actual clinical trials as well. So we can't claim that we offer, an all-in-one platform unless we help you in every single stage of your work. So I'm going to very briefly go through some of the features that we can offer to researchers to help them along the way. And after that, I'm going to focus on the data collection part. So we start with the eligibility screening. We offer eligibility and pre-screening. It could be one step or a two-step process. And you can basically you can have a, let's say, a complex version of this would be you have a social campaign that you put a QR code on your campaign, an advertisement, for example, and then people scan the QR code. They directly jump to a survey as an example. You can set any criteria for your eligibility screening, and it actually let them know that whether they are eligible to participate in this study as well or not. And on your side, on the researcher dashboard, you'll see you have full audit log on the and you have exposure on the entire process. So you know that who has joined, what's the status, whether they were eligible or not, and the next steps. This process could be automated or it could be handled manually as well. And of course, we offer electronic consent data collection as well, which could be based on, pressing simply, could be a press of a button, or it could be digital signature. It offers very complex scenarios as well. It could be if people, the participants cohort are going to be of legal age, we can directly send this to them. Or if they are underage, we support guardian consent form, which you can reach out to guardians, and then, underage people, or, any other combination that you like. It also offers a multi-step consent data collection as well, which one or more person on the participant side, could be caregivers as well, can consent, and as the same for the clinicians and research staff as well. So we help with the recruitment part in general. This doesn't mean that we offer participant pool. That's the only part that we actually don't, that's the only feature that we don't offer. But we can facilitate and simplify the recruitment process. For example, it could be we allow people to join your projects using QR codes, a registration link and registration code, or simply, we offer a dedicated web page to your different projects that introduces the project, which is nicely arranged, interface, and they can say, hey, I want to participate, and then it walks them through the next steps. When it comes to form-based data collection, we offer questionnaires and surveys, ecological momentary assessment, and when it comes to clinical trials, CRFs, EPROs, and other features here. This is the core unit of our platform that, and when it comes to survey data collection in general, we go above and beyond. We offer on top of straightforward features such as different question types, and piping variables. We offer randomizations. We allow you to use criteria without coding to automatically customize the flow of your questionnaires, and also customize the behavior of the rest of your protocol based on the answers that you collect from your participants. It could be, used for randomization of your cohorts. It could be delivering an intervention for a specific arm in your participant cohort, and rest of the stuff. So, survey data is one form of data type that we allow researchers to collect from participants. On top of that, we offer sensor data and variables as well. So we offer any sensor embedded on smartphones that's covered under Avicenna's platform. It could be, from Android and iOS as well. And the experience would be consistent across all these platforms. And on top of that, we have a wide range of, wearables that we support, such as Garmin, which we have deep integration and partnership with Garmin platform. We can pull data from API, Garmin Health API, Garmin Connect API, as well as from the Garmin SDK. We also offer a custom Garmin watch app that allows you to directly modify the behavior of Garmin watches, and then customize it for your research in general, and also customize the way that you want to pull data from these wearables. Beside from Garmin, we also offer Fitbit, Whoop. We're working on Aura rings right now, and smart scales, Exoskin devices, skin device, as well as, Backtrack Skin, and we're working with Mirror Care for in women health to collect hormone data as well. And there's a long list of wearables that we support. So next data type here is the cognitive assessment. We offer embedded cognitive tasks inside our platform, which again, the beauty of that is that everything is offered in that single platform on that single app that participants use. So it increases the compliance rate because they don't have to actually switch between platforms, create different accounts, and learn how to work with, different platforms. And also, it allows us to capture literally any data that you like while they are interacting with these cognitive tasks. And like, for example, a detailed time-stamped information of every single interaction. And also, it's very embedded, with the rest of the protocol. So, for example, you can trigger this automatically for a certain arm on your study, or it could be publicly available to all participants. The other part is that the meteorologic data, we can pull weather quality, wind rate, temperature, and everything, for the geographic location of your participants on an individual level. And then we can use these data for, to modify and customize the behavior of the app, interventions that you have, or simply just pull this data for observational projects. We're working on EHR and EMR data integration as well. So it allows us to also pull and push data to electronic records, health records in general. These are different data types that we offer. That's, the highlights of the platform. We do offer some other data types as well. But on top of all of this, we allow you to go one step beyond, what's a simple data collection platform offers, and to increase the compliance rate of your participants, to implement sophisticated protocols for innovative solutions, for example, or interventional projects. One of these features is just-in-time interventions. So when possible, we allow you to use the data that you're collecting from your participants in real time, analyze it with or without AI models, or if you have that, sure, like the AI models that you've trained to receive the data and then customize interventions, we can use those. Or if you simply have a state machine or a simple algorithm that allows you to analyze the data and based on certain thresholds, trigger different interventions for different arms of your projects. You can also do that as well. When it's possible, it triggers interventions within minutes. And when it's not possible, within hours or the moment that we receive the data from different platforms. When it comes to sensor data from smartphones, it's almost instant, but some wearables such as Fitbit doesn't allow us to pull data frequently and within minutes. So when it comes to these ecosystems, the delay is more pronounced. To increase the compliance rate of participants, we also offer gamification systems to jazz up the participant journey a little bit. That helps participants, like specifically, on the age, certain demographics of people, to stay engaged with the course of the project, especially in long projects. That the way it works is that it assign points to data that they're contributing to. And based on the points, they've received badges, medals, and different things which is fully customized for your demographics. Um, we also support, virtual clinical trials in general, remote clinical trials, by offering a full suite of televisiting features, which allows you to create one-to-one, one-to-many rooms with your patients and with other research staff, and then chat with them, send and receive, text messages, initiate phone calls and video calls, And when possible, you can, this is one use case of that. For example, if they were a polar device for heart rate measurement, you can remotely train them and in real time, you can collect their heart rate data and then while they are actually, and remotely, I mean, adjust the difficulty level of our exercise or workouts through our televisit feature. That's one of the use cases of televisit as an example. So we offer full compliance monitoring features. For that, we have three different sets of features. One is the Kibana from Elk platform from Elasticsearch, basically. So we offer full integration with this visualization tool. On top of that, we offer, you can export your data directly from your research dashboard in any format that you like. And the sky is the limit when it comes to that. And on next to that, we offer some visualizations, customized visualizations for your project as well, which I will present that to you at the end of the session. So you can also communicate with your participants through smart notifications and reminders. We offer three channels: SMS, email, and in-app notifications, which simplifies, the communication with your participants in different research protocols. So I'm going to shift the focus of the rest of the conversation to, data collection. And I'm going to focus on GPS data specifically because that's one of the controversial ones. Super duper hard to collect that through consistently and continuously in different platforms, here, Android and iOS. And it's very challenging because it exposes the platform to different, challenges here. So when we talk about continuous data collection in any form, there are some risks involved in the process. For example, it drains the battery faster because you're hitting the GPS sensor every time that you want to pull the data and get the location from the phone. GPS data could be considered as a identifiable information because of the details that it actually exposes to from the participants' perspective. It also it's not consistent because if you're in downtown in a very populated area, the GPS signal would be jittery. We have noise that we need to uh, deal with. Or, for example, sometimes you don't even have in mountain areas, as an example, you don't even have the signal. On top of all of these challenges, we need to collect this data from smartphones. And there are tons of variations and limitations when it comes to smartphones. Sometimes reading raw data from one platform is not possible. Sometimes, the way that a platform offers the data would be different from the other platforms. And also, for example, if you're collecting GPS data from an app, the operating system of that phone might actually right away kill that app, which adds to the challenge here. So also the behavior of data collection, because it's different, the completeness of the data and the gaps in between would be also challenging here, how to face with all these issues. And because GPS drains the battery and it also exposes a lot of information from participants. Sometimes they don't like to share GPS data unless it has a very uh, what's that tangible value for them. They might actually not like to share their GPS data, and that collecting GPS data from smartphones is only doable through via if they grant permission. That's the only way to collect the GPS data. So how did we uh, tackle all these challenges and issues? So first of all, when it comes to, I'm going to start from the participant app, and then after that, the pipeline, and after that, the researcher dashboard. So in the participant application, first of all, they need to grant permission, and we to be able to for the app to be able to collect the GPS data. And Basically, sometimes participants forget to grant this, and days passes, and you don't have any data as a researcher, and then it's already late to actually reach out to them and say, hey, for example, you're not sharing the data. For all these issues, we help. We actually have this alert bar on top of the homepage of the screen of the Avicenna application that help them to understand if anything is wrong with the settings of their phone. For example, if we automatically check when it comes to Android devices, we automatically check the model of the Android and see if there are any settings that we need to apply to prevent the app from dying in the background, or for example, grant permissions for the GPS data collection. And we provide all these instructions right on the homepage of the application to participants. And the same goes for iOS devices, which, as you know, if you put a iOS application in the background, the operating system automatically kills it very quickly. So we need to find a way to keep the app alive in the background. So we need the GPS permission from the participants to be able to keep the app alive in the background. But let's say all of these are good, the happy scenario here, and we can collect the GPS data. Now, the problem is that it drains the battery very quickly. And you can continuously, collect the GPS data. To solve this issue, first of all, we notice that sometimes other applications are using GPS data, and whenever we want to get the GPS data, an updated record from satellite, we don't have to hit the GPS sensor and pull this data from satellite again. Sometimes the Wi-Fi offers the same quality data. Sometimes cell towers offer the data. So the first step was to accept all this data and provide all the details to researchers to know that, hey, this is the source of the data that you collected. This is satellite, this is Wi-Fi, this is cell networks. And sometimes another application such as Google Map or Apple Map has already received the data and is very fresh and up to date. So we don't have to, get data again from the GPS sensor. We can rely on the data that we received a second ago, as an example. But another problem was that still we hit the GPS sensor a lot, and it still drains the battery very quickly. So to fix this issue, we designed the app to not continuously collect the GPS data, but do it in a periodic way. So our app currently collect the data for 1 full minute every 5 minutes. So uh, details aside, why we actually said it this way, basically, within that 1 minute of data collection, continuous data collection, we shoot for the best accuracy that's possible to collect from that GPS sensor on that smartphone. And then if we receive 3 good samples of GPS record, updated ones, of course, we stop the data collection right away. But if we notice that, for example, the accuracy, because we receive the accuracy readings as well, is not enough, is not at its best, we continue for that full minute to receive the data, and then after that we stop, we wait for 4 minutes, and then after that we hit the sensor again for 1 full minute. So sometimes if you are in a very good, in the area that it has good satellite reception, you get 3 signals, 4 signals, and that's it. Sometimes you are in towers in downtown areas, for example, then the signal would be jittery, so naturally you'll see more GPS records. But again, this was draining too much. So in a research that we wanted to work with a government of South Africa, we wanted to check the mobility, the effect of mobility of people on the HIV spread. So it was supposed to run on Android devices, kind of low-end devices, and in rural areas without proper access to electricity and internet connection. So we wanted to know that how we can actually even improve it a little bit better. So we added to this logic again to for more efficiency. We imagined this scenario that, hey, what happens if my phone is on my desk all day long, and every 5 minutes I hit the GPS sensor again to get the location, knowing that that phone is not even moved. So why should we hit the, GPS sensor again? So to avoid this, we designed an algorithm to automatically use other motion-based data, such as sensors, such as gyroscope and acceleration, to detect whether the phone is actually moving in any form. And if it is, in the next, data collection cycle, we ask the GPS to, give us a new location. But if it's not moved, we report the previous location. Now you might actually ask why we don't even report this? Because the reason is that we want to help with the data analysis part, because we wanted to know that if in every cycle of data collection, we wanted to consistently report the current location of participants. Okay, so we collect the data. Let's say the GPS data is collected. It's saved on the phone. We use Google Protobuf basically to save and transfer the data. So here's the pipeline. I want to quickly walk you through the pipeline of how we move data from um, phones to database, and how basically all the way to the point that researchers would have access to data. Let me just minimize this window a little bit here. Okay, so let's say the first box on top of the screen, you see that the phone has uploaded the data, and the servers, by default in Canada, our servers are located in Canada, receive the data. So first of all, it reads the protobuf binary data, and then it extracts the study and logs data, because we also offer a full audit log because of the HIPAA compliancy, of course. And then it checks whether the first step is to parse and validate the data. Why do we do that? First of all, parsing is obviously because we want to detect the type of the data and then see where to save, how to treat the data. But the validation is actually very important, because things that we do are going to be like this. We see whether we actually expect to receive data from these participants, from this device, for security purposes and all the other measurements, of course. And also whether the timestamp makes sense. Sometimes, phones send data inconsistently, or if for any reason the local instance of the data is not removed properly. Let's say halfway through the data upload, the phone has died, and then, all these scenarios. So we check timestamps, the number of the records and everything, make sure that the data is supposed to be received and it's healthy data. If it's not validated, we reject the data. However, we save the data in a separate place. But if it's it's a valid data, then we put data in data models, protobuf data models. Now, when it comes to saving the data, we have different databases: Cassandra database, Elasticsearch, as well as HDF5. I'm going to skip the third one. We do also offer PostgreSQL here as well, but Postgres database, which is going to be part of the Cassandra. So let me a little bit forward. So let's say I'm going to go this route from Cassandra perspective and Elasticsearch. So when we receive the data, we save the raw records on Cassandra, and we save on, depending on the volume of the data, if it's not too much space consuming, such as acceleration or gyroscope, which are, they could be 120 hertz, like 120 samples per second. If it's not the case, we also save that on Postgres. Now, the moment that we save the data, we start the data cleaning pipeline and the data analysis pipelines on our platform. For example, let's follow the very left route here. Let's say if we receive the GPS data, a scheduled job starts reading the data from Cassandra tables, and then it extract features from the GPS sensors, and adds a lot of, like, in terms of features like the distance traveled, duration, location entropy, and time at home, which I will present all of these to you in a second. And then it saves everything again in Elasticsearch, as you can see on the bottom of the screen. We also use Postgres on the right side of the screen to calculate and save some aggregated data. Why do we do that? Because when you look at the data from the data, it's data's perspective, aggregation might not actually be that much of a use. It's not useful as much. But if you think of it from the studies perspective, you want to have some overview of the health and quality of the data collection and everything. So that's how we basically separate the databases. There are a ton of other things and considerations into goes into this, but from the data flow perspective, that's it. So next page comes to the visualization part. This is the part that you see the data right on your research dashboard. So a visualization, what's that? We in our visualization dashboard, we check the quality metrics, for example, which you'll see how we actually set that. And then based on that, we offer some endpoints to our front end, which is going to be the researcher dashboard, which you will use this API to pull data in your queries, and you can draw charts and visualizations based on what you want. We use a combination of Elasticsearch and Cassandra for this case as well. So depending on the type of the data, of course. So this allows us to serve you in two different ways. One is we can provide you with API endpoints, so you can directly pull data from these databases, which allows you to further, integrate it with your workflows. If you have your own servers at Michigan, for example, you can completely customize the entire platform, for your research work. Or you can simply use, your researcher dashboard for that. And this brings us to a researcher dashboard, which I'm going to share my screen here. Just switch to this tab. Okay. Can you see my screen?
Yeah. Yes.
Great. Okay. So I need to refresh this page because I can see an error here on my side. There you go. Okay. So what I'm going to show you here is a new feature that we've been working on for a while. We're going to release this dashboard in a month or two. And this feature, which I'm actually very excited for, is it allows researchers to have insight and have full exposure on participant journey, the way that we actually collect the data, the health of your project, and is fully customizable. So when we talk about, a project, and we need to think of it from four different categories. One category is the study itself, which is an umbrella for all, different types and participants and stuff. On the other side is from the data types perspective. For example, GPS acceleration, what's the health of the research or the compliance rate based on that specific data type? The other part is participants, which you'll see what's the compliance rate of this participant, what's the participant journey during this time window, as an example. And last but not least, of course, is the intersection of participants and data sources. So you can see that what's the compliance rate or the experience of this participant when uploading this specific data. And you can adjust all these settings right on your dashboard as well to have a customized visualizations for your project. So these four tabs on top of the screen are basically the ones that I mentioned, but I'm going to start with the settings because here you can see what's going on exactly, and you can set how exactly the visualization is supposed to happen. So let's say right now it only focuses on GPS data, which we talked already. So let's say if we have here, to be able to do these visualizations, that GPS is not the only data that we collect. So there should be a unit that is common in all different data types that we're collecting. For us, that unit of measurement is the number of the records. I mean, cleaned, good quality records within an hour. Then based on that, we can customize and visualize everything. like the compliance rate and the quality of the data that we collected and the rest of the story. So here you can say, um, you can set a quality score for your project based on the number of the records that you expect to receive on an hourly basis for this specific data type from your participant. For example, if you say that, hey, 200 is the absolute perfect number of the records that I'm expecting to receive from participants, to call that 1 hour a full compliant excellent, for example. And I mean, that's the max that we might actually get. So you set this here, and then here on the bottom of the screen, you can score your the quality of the data that you're collecting from your participants on an hourly basis. For example, you can say, if I receive 80% compliance out of these 200 records, then I want to call it an excellent compliance, right? All of these are to help you with like simplifying the compliance rate monitoring, because by looking at your data, you can easily say that, oh, hey, for example, this participant has an excellent record score. This means that you know that on average, over 80% of the data are uploaded on an hourly basis. And the same for green, which is good here. So for example, anything between 60% of the max number, which is 200 here, up to 80%. And the same for moderate. And we have color coded everything here. Now that everything is set, you can save the settings here, which this one is already saved. And then the moment that you do this, it customizes and updates all of your visualizations based on that. Now let's go to the um, exciting part. So let's start with this study. In the study, you can say, hey, I want to do visualizations. I want to see all these details and insight analysis of my study for the last 60 days. You can change all of this, of course. So in this window, we have let me just minimize this screen a little bit again. There you go. So in this screen, in this panel, you have study level metrics, which very briefly show you and quickly show you that, hey, what's going on in my study? For example, the quality distribution of my participants. In this project, it says over like 32% of participants, around 32% of participants, the quality of the GPS data upload is excellent, which is the average quality on an hourly basis, as we discussed. So, and there are, like, for example, 46% are in good state, and the rest of the story. And this study had 93 participants, and the overall quality across all participants, while they've been enrolled in this project, was like 69% or 0.69. The next panel has the same information, but on a daily basis. So, for example, uh, in the last 60 days, you can see that what are these stats on a daily basis. And we also show you this calendar-like view for all of your participants. And this is very interesting when you actually look at this a sample project, which was the data collection period, I would say, was like a couple of weeks at least. And you can see that they've probably done rolling enrollment. For example, participant joined and they uploaded data for these, from during this time window. And then again, next batch has started collecting data. And the red ones are basically the times that no data was uploaded, of course. So you might actually ask how's that possible to very quickly, update and do these visualizations. This is thanks to, the way that we save the data. If you notice that, it goes back to the previous slides, we extract features from Cassandra and Elastic, and then we save we extract all these features and we save these features right on Postgres and Elastic, so you can pull this data and present this data very quickly. And also, some of these charts, they allow you to export the data and download, or either in CSV format or an image from all these visualizations, which makes it super duper easy for any publication you want to have, or for example, if you want to share this data. Another cool feature that we offer here, I'm going to speed up a little bit because with respect to the time, is the retention rate here. So this is amazing that we can actually, first of all, this is based on Kaplan-Meier method that provides you with an estimation of You know, if you if your participants continue uploading data this way, that's the retention rate. And for example, in this project, it started with 100, of course, compliance rate. And I mean, in terms of like number of participants in the study, and then some of these participants dropped. And if we continue doing it this way, it goes down to 11%. So um, I'm gonna pass this, but this is a very powerful feature. And as you can see, we have this 50% mark is like 10 days, which means that within 10 days, you actually get you might actually lose 50% of your participant. That's the expectation. So we also offer some insights when it comes to engagements, for example. This one is the active participants per week. In general, if you want to know how many participants you had, and the cool feature about this is that on the x-axis, you have weeks here instead of like single dates. And here is the quality score, overall quality score for your projects on a weekly basis, which again, quality comes from the hourly quality of your data. And also we have insights on, you know, the device versus OS, what's the operating system of your participant devices. For example, here, you know that um, Apple is this one. Almost 39% of your participants were Apple users, and 40 Android and different models. The same goes for data quality by device, which is interesting to see that we have over 78% compliance rate on GPS on iOS devices, which is kind of unheard. And OS distribution, North America. This one is not North America, but and it actually makes sense. I believe this study was conducted in Hong Kong, so which is again more challenging to collect the GPS data. And data quality by OS, again, this is Android versus iOS. So data source, this is only GPS, so I'm gonna skip this one. But let's say if this is an interesting part that I'd like to show, data source, an intersection of data source and participants. Let me select one participant, for example, 6221. 6221. Let me see. One of these participants, but it was a very good example. 136, 136. Okay. This one. Okay. And everything is good. I'm going to set it to 90 days because this study, I believe, is finished. So you can see that the daily GPS activity level for this participant, the number of the records count, the hourly coverage here, and also you can select the day here, which you see that this the last day is selected. And then you can see the mobility patterns. For example, the distance they traveled, the duration, all of these are, very useful information when it comes to location data analysis and mobility analysis. The entropy when it comes to that, and time at home, which we calculate that for you. For example, we know that we consider the time that they spend nights or what's that they stay on overnight and as home as we move forward, and we calibrate the data based on that. And that's how we calculated this. And GPS points per hour. And also we have integration with a GIS here, which you can actually see the distance what's that, the trajectories of GPS here, which this is in Hong Kong, which is here. This is for one day. That's the number of the records. You can also modify this as well. I'm gonna pause here. That was, I think, a good overview of the, from the moment that we collect the data from participants all the way to this visualization platform, and to give you room for some question and answers.